Rolling. Right, good evening, everyone, and welcome to our CAWASA Wednesday webinars. This is number 8 in our series, and already we have some 20 persons online, so I'm sure the numbers will increase. I think we have an exciting topic, which is really very timely with a lot of what is taking place with the water sector. We will be hearing of the commercial water reuse, and we will have a case study presented by Mr. Sam Neilands. And Sam is no stranger to the water sector, having had some considerable time in working around the Caribbean, and not just around the Caribbean, but he has been working in the water and wastewater industry, and completed his environmental engineering degree at the University of Guelph, Canada in 2005. Since then, he has touched on every aspect of the industry, starting with plant operation and moving on to installation, commissioning, design, project management, and finally sales and business development at Ecohesion. He is the Director for Business Development in the Caribbean region at Ecohesion Integrated Sustainability Company. And I believe that he is based in Barbados from time to time. And so without further ado, I will now invite Sam to take the floor.
Thanks, Ignatius. Thanks for hosting, as usual. Good to see all the regular names and faces. Yeah, I think all the complaints about me there are true. I am situated in Barbados. That's where I'm working out of. By the moment, I'm actually in Washington, D.C., and back and forth between here and Barbados, just due to family reasons. I have a short presentation for you all, and I hope to just open up the floor to discussion after a short time. I think it's just basing everything on, where we're advancing in terms of water and wastewater treatment over the next little while. And the fact that, in terms of climate change, we are certainly on the forefront of it here and on the battlefield in the Caribbean, where we may not have caused a lot of the issues, but we certainly are dealing with them firsthand. And I think that's why forums like this are very important. And I think us all banding together is very important. And I'd just like to share a little bit about one of the case studies that we have in Barbados. That's a pretty nice one, and I'll switch over to that now. So I'm going to turn my video off just for the presentation because it's just a little easier to do it that way. And I'll share my screen. So let me know once everyone sees that. Okay.
Yeah, we can see that. You might just want, that's great.
Yeah, all good?
All good.
Okay, great. So just to start off, I'd like to do a little background on Ecohesion and integrated and what we really do. We are specialists in the wastewater and water treatment field. We kind of do the full circle, an end-to-end service. We do everything from the very beginning, consulting when developers are just starting off on a mission to build something new, and we go through the full cycle of design, build, operate, testing, programming, monitoring, support, and continue to keep those assets living through the life cycle for the clients. So our main focus is really on the operations side of things. That's where we started. It's a monthly contract style system that we operate. We do have a couple of also utility style contracts where we sell water as a service, but I'll get into that at a later time. Across the board, integrated and Ecohesion also, you know, cover a lot of the various topics across climate change, water. We do a lot of work in water, and in the Caribbean, that's our main focus. Sustainability, obviously, that goes hand in hand with the water work that we're doing in the Caribbean. But the broader company also works across the globe with sustainability projects, data management, environmental and regulatory, which we dip into as well a lot in the Caribbean, waste, obviously, as well. The renewable energy. This is done mostly through the parent company there in Canada and in North America. And operations, as I mentioned, is a kind of core actually from the Caribbean going out towards North America. So that's built around our offices in the Caribbean. Talking about offices, yes, we're mostly located in North America with integrated sustainability having over 100 employees up in the western region of Canada, which Valerie would be familiar with. But we also have offices in Houston, Texas. We also have one now this is actually not updated. Actually have one now in California as well. I'm obviously located here in DC, but our main Caribbean office is Barbados. In the Caribbean, we do have a number of offices. Actually, we have St. Lucia, Barbados, and Bermuda. And we have staff that are permanent staff in Antigua as well, and Trinidad. And then we support operations in Grenada and St. Vincent, Guyana, and of course the main staple is Barbados, where we have about 20 of the 30 employees for the Caribbean. We have just over 30 treatment plants throughout the Caribbean. They're all predominantly wastewater treatment, and they're tertiary or advanced water treatment systems. We also have a number of water treatment systems, seawater, RO, and things like that. A couple of UF systems. We treat about 200 or 2.3 million gallons per day, and that's for reuse water. So we're treating wastewater into reusable water, which is what this case study will be about. And yeah, as I mentioned, about 35 regional employees, all dedicated to that water sector, and spread out across predominantly eight of the Caribbean islands. And that's on the operational side. And of course, on the sales, we also spread that umbrella a little bit and do offer services into other islands as well. French and Spanish speaking is included. What I wanted to go through here was, taking the water system as a whole and looking at it through a circular lens. Wastewater really should be considered as a renewable source for clean water, fertilizer, and power. And all these things are possible with the advanced technology that is available at this time. So I'm going to show you one of the case studies that we have of the villages at Coverley. And just before that, I'm going to just walk you through, and I'm sure everybody on this call is fully aware, just the general breakdown of treatment. So I mentioned that most of our systems are advanced treatment systems. The majority of those are ultrafiltration. So they're membrane bioreactors. But of course, we can couple those with reverse osmosis to get even higher purity of water, or and that's actually what's being called for now in the latest Barbados Water Authority requests. So I think many people might be aware that Barbados Water Authority is looking to take their existing primary systems and upgrade them to advanced treatment systems for water reuse. And those will include, ultrafiltration to some degree, and then a reverse osmosis as a final stage to actually take the water to a level which is considered drinking water, but would be used for crop irrigation and indirect aquifer recharge. Anyhow, so the general steps are your pre-treatment or primary area. As I mentioned, that's the Barbados Water Authority South Coast system is a primary system only. It removes grit, fine screens stuff, and also can do some flotation where it would remove some grease and things like that. So that's considered your pre-treatment or primary stage. Then you get into the secondary, which is usually includes some kind of biological treatment. You can have obviously the anaerobic process. You can have an aerobic process, which the MBR system would be. And then you would have some solid separation due to settling, right? But there's no physical screening. When you go to advanced treatment, then you're talking about physical separation of solids. So with the ultrafiltration membrane, you're pulling clean water through a membrane, and anything that's above 0.04 microns, which is smaller than, let's say, bacteria and viruses, that all gets retained back in the wastewater side of things. A number of our systems will stop at the ultrafiltration step, and then we have some others that would then polish that water further with either activated carbon or reverse osmosis, and then after that, obviously, you're going to need some kind of disinfection. We consider disinfection after ultrafiltration as a secondary step, usually is for the distribution system. So it's really for residual disinfection. But there are systems where the requirements, dictated in different areas where, they will look for a double step. So they want to hit the disinfection with UV and then also have that residual disinfection with some chlorine in the distribution system. Of course, when you're talking about primary systems, secondary systems, or advanced systems, you still have a waste stream, and that's the solids that are built up, that are retained, and there needs to be something to do to treat those as well. So I'm gonna show you a case study that kind of hits a lot of these boxes in Barbados, and that is here under our reclaimed water project profile. So I'm not sure if anyone is familiar with the villages at Coverley, but let's give a brief overview on the development itself. It is a housing development, as you can see, split into different villas named after fruit around the Caribbean. You have a central area here, which is the kind of circular area. I don't know if you can see my mouse. Here in the middle here, there's a main town square. So there's an area with, restaurants and shops and that sort of thing. So people kind of generally hang out here in the town square. Has some offices as well. Mostly they're shops. There's a gym, gas station, big football field, and they have a basketball court, etc. So this is kind of the town center. And then out from there you have it's like 1,250 homes, and they're all sort of mid-income homes, supposed to be affordably priced, and we operate the wastewater treatment system that actually collects wastewater from all the homes, and that's all wastewater, and we actually treat that wastewater with MBR technology, and we add chlorine residual and send it back out for reuse. And the reuse is piped back along all these roads, so there's a full distribution system for the reuse. It goes to every single home, and the residents actually have then they have dual plumbing, right? And they have 2 water meters, and one of them is for the water from the Barbados Water Authority, their drinking water. And the second meter is from the reuse water, which is from us. And that is it's connected to the toilets to flush the toilets. And it's connected to all the outdoor taps for watering the garden and, washing cars and things like that. I'm going to go into that a little bit further here. Zoomed in, this is off a picture off of Google Earth. So I've zoomed into the area where the wastewater treatment plant is, and you can see it is surrounded by the houses right there, very close to it. It's a fairly compact footprint because this is a small part of the neighborhood. It's actually 31 meters by 19, and that's in that little blue square. It's a kind of granular picture, so you can't see too well, but I'm going to show you a breakdown of how that plant actually is laid out and works. But essentially, all of the tanks and equipment are within that blue square. The 2 big round tanks are the treated water storage, so the reuse water is stored in those tanks. And then the small rectangle over on the top right here is where we have just the distribution pumps that pump the water back out through the villages. So yeah, I mentioned, I think a little bit earlier, this development was built for 1,250 homes. It's actually built for 450,000 gallons, US gallons per day of treatment. It is tertiary treatment, as I said, with MBR technology, and I'll go through it a little bit more. The footprint I mentioned already as well. I mentioned also the reuse water being distributed to every house. I'm going to talk about the uses of the water. And it was built actually in 2008. So it is an advanced water treatment plant, but this is part of the planning of the developer was to include this. And I'm proud to say that we installed it in 2008 and have been operating it since then. So it is sort of a flagship in Barbados in terms of commercial reuse, I would say, but not in terms of MBR, because in fact, I think our first MBRs were installed around year 2000. So this exceeds the EPD requirements, which is the Environmental Protection Department in Barbados. And it provides the landlord with some savings on their water bill. As you can imagine, a development of this size would have a large water demand. And with the reuse of the wastewater, we're able to save them, upwards of 60% on the water usage for the whole development. Because all this.
Can I just interject? Ignatius phoned me. He's having some technical difficulties. I can hear you fine and see you. Is everybody else, Kevin, Selena, are you hearing and seeing okay? Just want to check in.
Yeah, I hear and see everything.
Great.
Yep. Yeah.
So, yeah, me too. So just at Ignatius's end then. Sorry to interject.
No, all good. I'm happy you did, because I wouldn't like to be speaking the whole time and no one's hearing me. That's for sure.
I was hearing you.
Okay, good. Well, I'll continue now that we're clear there. Okay. So the savings is not just through monetary savings, because obviously having a commercial reuse where the water is charged to clients actually helps to cover the cost of operating the plant and to pay back for the initial capital investment. But obviously it's a huge savings to the environment as well, because we're stopping raw wastewater from going into the environment. We're treating it to a very high level, and then we're able to reuse that water, saving more potable water. So it's a very green initiative. So I'll go into a little details here because obviously we have a technical group. So stop me if anybody is really bored, but I'm going to try and go through this. This is the plant design. This is the kind of plant layout that we have. I don't know. I'm hoping that you guys can see my mouse. I'm not sure. Can everyone see
Yes.
my? Yeah, you
Yep,
can.
yep.
Great. So the system is actually split into two phases, right? You have, oops, you have your first phase, which is the top half, and you have your second phase, which is the bottom half. And essentially, the tanks are buried underneath and partially buried into the ground. And then the building is actually built above the tanks. So the process building is above the tanks. The first tank you come into here is an equalization tank, and it's split into two for the two phases. That raw wastewater is collected in there and is pumped up into our screening system, which automatically removes the solids, washes and compacts them and puts them into a plastic bag, right? The raw wastewater goes forward into an anoxic zone, which is underneath this area here. This is phase one anoxic zone. That anoxic zone spills over into the aerobic zone, which is underneath this building here, in this whole area. That water then falls over into the post-anoxic zone, another anoxic zone following the aerobic. And then the water goes into the membrane tank, which is here. The solids are then recirculated from the membrane tank here back to the beginning of the aerobic, as well as from the internal recirculation from the aerobic tank here to the anoxic, the first anoxic zone. And these pumps in the membrane, they do about 5 times the flow of the plant. So you get really good mixing throughout. And then these pumps in the internal recirculation do about 3 times the flow of the plant. And that's just to make sure that we have as much contact with the bugs and the microbes in each of the zones as we can, right? Because the more contact time, the more the food is degraded and the more biologically the system does its work. So all I've described there is basically conventional in terms of treatment, and a secondary treatment because it's just the biological step, right? And that the only difference with this MBR technology is that the solids concentration is a lot higher than what a conventional system would be. So while a conventional system may be around 2,000 milligrams per liter of biomass, these systems are meant to operate at 8,000 to 10,000. So it means that the footprint can be squeezed down a lot. So in this small space, this first phase, we can do about 200,000 gallons, and then if we open up to the second phase, we can double that. So here's the tertiary step comes in, is where the membranes come into play, and essentially these membranes are hollow fiber membranes, and they're submerged into the biomass. We have a permeate skid here in green, and the permeate pumps basically pull the clean water through the membranes and into the skid, into the pump and out the other side, right? So that clean water gets pulled straight through, and then it's discharged into a chlorine contact chamber tank, which is the very last tank here. And then from here, it's pumped over to the big circular tanks that I showed you in the aerial shot. We have, of course, air blowers, so to provide air into the aerobic section. We have blowers here as well that are for scouring of the membranes. And the air scours the membranes to try and keep the solids in suspension and keep them from sticking to the membranes, essentially. keeps the membranes clean. And then the second mode of cleaning the membranes is what we do is back pulse the cleaned water back through the membranes, and it basically is like almost like sweating, where the water comes through the pores of the membranes and clears them, right? So we'll do that with just treated water, and then sometimes we will add chlorine to it to help just disinfect the membrane and just help clear it, push the solids out. Talking about solids, then we actually have this large machine here in the back, and I'll show you some more detail on that. That is a dewatering sludge press. So what that does is it takes the solids that are being built up within the system, because we're taking clean water out and we're obviously building solids every day. So this machine will dewater, take all the water out of the sludge, and leave us with a dry cake that's easier to transport and dispose of, right? So instead of having to take tankers of sludge, which is mostly water, you're ending up taking something that looks more like a fertilizer, like a compost, and in fact it does go to the compost. The rest of this area here, there's some compressors just for different hydraulic systems, and then we have a chemical room and some chemical dosing. So I mentioned the chlorine obviously is used for residual disinfection, as well as chlorine contact chamber time here. We also use it for cleaning of the membranes. We also have sodium hydroxide and a pH control system, just to keep the pH kind of balanced. And in fact, with the multiple anoxic zones, this system sort of keeps its own, regulates itself, and we don't really have to dose that much sodium hydroxide for this particular system. And we also dose alum so that we can reduce phosphorus down below the requirement, which is less than 1 milligrams per liter. The membranes are picked up on this long beam here is essentially just a crane, so that we can lift the membranes out of the membrane tank, put them in this middle tank, which is a chlorine, like a chamber, for cleaning, and then we can do like a physical clean on the membranes, and we do that every 3 or 4 months as needed. Here's some pictures of the outside of the facility. If you remember exactly, these are the tanks I was referring to. So the tanks start here and they go about 20 feet deep underground, and then the building is precast and it sits above the tanks. So this area out here is actually the equalization tanks that I showed you in the previous slide out here. So that picture is taken from this angle out here, looking towards the plant. You have your final lifting station, which is outside here, which is not shown in the drawings. And so the water is lifted up and into the equalization tank here. Obviously a backup generator, etc. This is the crane that I was mentioning in the background. And these are the reuse tanks, which I was also mentioning in the overhead picture. So these are just very basic tanks, galvanized tanks with a liner on the inside. And you can see that the piping is all color coded. So the purple piping is the reuse water. And in fact, one is a drain here and one is an overflow to the well. And the blue line in the background there is the Barbados Water Authority top up. So in the event that for some reason the wastewater treatment is down and we don't have enough reuse water to send out to the villages, we actually have to top it up with fresh water. But we hardly ever have to use that, obviously, and that's the point. If you were supplying, if you're using drinking water to, for example, water the football field and fill the fish ponds, etc., you would have to be using a ton of water, because we are doing right now an average of 100,000 gallons on the 200,000 gallon per day side of phase 1. The plant equipment, I'm going to go into a little bit more in detail. So I mentioned in the drawings, you can just see now a little bit better. We have these membrane blowers out in the corner here, and the process blowers at the front. This is the main control panel. It's all run off of a just a HMI and a PLC. We have remote connection to that, so we're able to look at it from home or on our phone, or just in the office within the plant. And again, the color coding is throughout, the purple piping being the clean reuse water. And the blue piping, wherever you see that, might be BWA water. And then the other color pipe is just chemical. Here's a better look at the pre-treatment and the post-treatment. So I mentioned the screening system, and this isn't the greatest shot because I can't see the whole thing, but effectively there's a drum in here, and the raw wastewater comes into there, and that drum spins, and it has a perforated plate to it, so it lets just the water through, and anything above 3 millimeters is retained. There's a auger, like a screw, that takes that trash and takes it up this neck, and basically compacts it here at the top and washes it with reuse water to clean the actual trash. And it dries because of the elevation, it drains back, and then that dry material is dumped into an automatic bagger here. And what our operators will do is come around every period, every morning probably, and they will just close the top of the bag and take out the old one, and then it continues to fill. So it's like a endless bagger. So that's on the pre-treatment side. And then on the post-treatment side, I mentioned the dewatering sludge press. Here has just been serviced, so it's clean and open. But effectively, this is sort of very similar to the pre-treatment, but it's you're actually taking the sludge, you're adding a flocculant and a coagulant to it, to really thicken it up and let it congeal together. And then you're putting it through this system, which is a much finer screen, and you're essentially pressing the water out of the sludge. A bit like, I don't know, yeah, like squeezing mud until the water comes out. But we use chemicals to help facilitate that, right? And then we have a drum that goes here on the end of the system, and it picks up the dry solids, and it just gets wheeled out to a skip bin. And from there it goes to the compost. Again, you see all the purple piping coming there. All the water that we use for the process is all the reuse water. So we don't use any drinking water inside the plant other than for, cleaning your hands, washing your eyes if you need to, or anything like that. This is the dream team here that operates at COVRI. This is the majority of our staff here in Barbados, that work on the system. And this is a picture of the biomass outside. And what I wanted to share here was that the real work, or behind the scenes work, is done by the biomicrobes, which you can't see in here. But a professor of mine always used to say, if you're taking care of a wastewater system, you just got to take care of the bugs. Once the bugs are happy, then everybody's happy, right? Now, of course, that's relatively simplified because the process needs to be taken care of, but obviously all the equipment needs to be working as well. So for that, we have a team, as I mentioned. I showed some pictures there. They tirelessly work on a number of different aspects of the plant to keep things going. Obviously, you have your electrical maintenance and monitoring. You have your field testing. So in this case, I think Ron might be using either a pH or a DO probe to just double check that all the automated probes and everything are calibrated and running up to spec. Over here, we have our lab tech basically having a look at the biomass itself. looking at the microbes and the health of that sludge, to make sure that it is in full optimum condition. Because effectively we're still using a natural process here where the biology is breaking down the wastewater, and so we just want to make sure that our biology, our microbes, are in the best condition possible so that they can do the best work. I mentioned the system is automated, so you know, a large component of it is the PLC, the programmable logic computer. And our technicians are all capable of programming and changing and updating and doing whatever's needed to keep systems running. So that's just a shot here of some troubleshooting that might have been going on, or an upgrade. Yeah, of course, we have our regular testing, and this is just a shot of the clean water coming out the end of the reuse. But we do testing full parameters on influent and effluent 3 times a week, and that's for the full complement of, you know, BOD, COD, TN, TSS, TP, pH, temperature, you know, all the various components. We do all that in-house testing with our lab inside of this facility, actually. And we actually test a lot of the other plants around Barbados with this same lab. We run pretty much all of our systems through there. Of course, you have your mechanical maintenance and your pump repair and pump, you know, greasing, and the general preventive maintenance that goes along with any kind of mechanical equipment. So that is taken care of. Just as an overview, the reuse water is actually used for a number of things throughout the development. They irrigate the football field and any green spaces with it. It's used for the fish ponds, and there's a lot of like koi ponds and things like that around the development to make it more aesthetic. The toilet flushing obviously is one of the main uses. You know, in everybody in their residential areas are using it to water the gardens, and use it to wash cars. It can be connected to the fire hydrants. And in fact, they use it for cleaning the streets and the development too. They have like one of those little street sweeper things that goes out with water every so often that uses reuse water. And in fact, on that note, when we had a massive disruption to Barbados at one point, obviously it wasn't as big a disruption as it was to St. Vincent, but when the volcano kicked up, and that was in 2021 or 2022, now I forget. But the sky went black with volcanic ash, and Barbados was, you know, dark in midday. And then we dealt with a severe island-wide cleanup. That was like, you know, there was like 4 to 6 inches of volcanic ash everywhere, all the roads, you know, the airport, everywhere. And there was also at the same time a water shortage, right? So BWA were saying, don't use the potable water. We do not have enough water to be sparing to wash down your house, wash down your roads, wash down anything. So in fact, we had a 24-hour operation going on here at the reuse water plant, where all the water trucks were coming to us to fill up and carry water to wash the streets and wash the airport and wash down everything. It was a massive national cleanup. And you know, it was then that you could see how much this type of system really can help, right? So that's just a thing there. This is you know, a list of some of the drinking water systems and wastewater systems we have throughout the Caribbean and some other places. It looks like it's relatively old. As I said, I probably should have updated this list as well, but that gives you a kind of idea of the overall thing. We have 15 minutes, so I might just skip through a couple of these things and go to the end so that we can have some time for questions. But I want to thank you very much for hosting me. And if there are no questions, I can go back to the last 2 slides, which essentially just talk about they just talk about our center of excellence that we're trying to promote this year, and some new pillars that we're trying to communicate across 2024. But thank you again for having me, and I'll open the floor to any questions.
All right, the floor is open. Thank you again for being with us this afternoon. I think it's really, we know that Ecohesion is around, but to get many of us, we've met with some of the Ecohesion team at our conference in Barbados last year.
Mhm.
I'm aware that Ecohesion has some different work doing around the region, so it's always good to get some drill down into exactly what you're doing. So that's welcome. So I invite the participants to please share your comments or questions. You can do so directly or through the chat room.
Yeah, and I'm sorry. Hopefully I wasn't too commercial there, but you know, I am in business development these days, whereas I used to be, you know, mostly the operator for a lot of these plants. I would say, you know, through the years I have touched on every different aspect of our company, and that's because I'm basically an entrepreneur, rather than anything else first. So I've had to do every single job in our company, and I think makes for a well-rounded presentation. But I try to stick towards more technical stuff, and you know, but not too boring to keep it in pictures. So hopefully it was relevant to the chat.
We have our first question in the chat. Is this facility development exclusive to reuse, or is the system scalable to receive wastewater from nearby developments and provide reuse services?
Yeah, it is expandable, because right now we're still in phase 1. So in fact, because it was installed in 2008 and now we're in 2024, we actually had some fairly major advancements in the membrane technology, which allowed us to, you know, continue to take more water in without having to really go to phase 2. So we have actually quite a lot of room to expand. Coverley itself is expanding, and they are doubling the size of their development. But even beyond that, we should have some capacity to treat beyond the development once it gets to its full extent. And we would like to maximize it, because I explain to the client all the time is that, you know, we're basically driving a bus there, you know, like a government bus, but it only has 10 people in it when it can hold 40. So what we want is a full bus, and that would be optimal for everybody, right? And on the same condition, whatever water we can't sell back to the development, it would be ideal to be able to sell that water off to nearby places. We have identified that there's like a plant nursery nearby, which would be a perfect place for reuse water, because I use a lot of water, and you know, right now it's potable, so be a perfect client.
Okay, we recognize Timothy Augustus, who has his hand up. Proceed, Timothy.
Yes, thank you. Professional operator out of Trinidad and Tobago. I envy Barbados and this system. It's, you know, one of my dream is to really have a system like that. I've been preaching water reuse for quite some time. How were you able to convince the residents or even the authority over there to have such a facility? Was it you know, what are some of the challenges involved in that?
Yeah, and that's a good question, actually. Yeah, and it was in 2008 when we were able to do this. But I would say the bottom line always comes down to commercial terms, right? And in this case, we were able to prove or show the developer that eventually, you know, with a full bus, they could actually pay back for this system in terms of the capital expense. as well as you know, help to cover the cost of the operation of the system. So because there is an actual commercial component in that we're charging for the reuse water, you're able to make it commercially viable, and therefore it's an easier sell. Now, when I say that, the water itself is sold at a discounted rate to drinking water, but at the same time, any value that you can get for that reuse water is something that helps, you know, your commercial model. So it was difficult, but in certain aspects we can actually be commercially viable, and that is what did the trick for this customer.
Yeah, we have a question from Ezekiel Francis in the chat. He asks, for those consumers who have both drinking water and reuse water from your system, do you have a separate metering system for them?
Yes, yeah, they have. So the drinking water is metered by the Barbados Water Authority, obviously, and they're the provider of the drinking water. So they will bill for that, and the reuse water is completely separate plumbing system and a completely separate water meter that's read by the developer and charged by the developer to the residents. And they also meter, obviously, all the landlord areas. So their operating company that runs the development does pay for their irrigation of their open spaces and things like that too. So the whole facility is dual plumbed, where you have blue lines for drinking water and you have purple lines completely separate for reuse water.
Next question from Mr. Owen Gill out of Trinidad. He asks, how do you handle FOGs? What is the range of your MLSS?
Yeah, fat, oil, and greases, those are generally dealt with. You know, the major components of those are in the town center, where they have restaurants, but they all have designed in grease traps, and that's sufficient once they're maintained. We do see FOGs reach the plant, but not in any concentration that will harm us, essentially. And then in terms of MLSS, we generally stay below 12,000. We stay between 8,000 milligrams per liter and 12,000. And with the help of the sludge press, we're able to, you know, keep that pretty consistent. So depending on what our loading is, I would say that this facility is still sort of seasonal, because a large component of the residents are students. So when the students are there, we run at one concentration, and when the students aren't there, we run at a different concentration. And we're able to keep that maintained and balanced with that sludge press. It helps us keep the cost down as well as keep it consistent.
Next question from Mr. Gary Pilgrim. He asks, is the reuse within the development an exclusive commercial arrangement to this development, or are tariffs in place or for set prices for reuse services?
This is a one-off in the case of Barbados for this particular development. It was done as a case study. So it's a case study of case studies, right? But I would say that it's being taken on because now Barbados Water Authority is actually moving to a similar system where they will be creating reuse water and charging for it as well. So I would say it's a successful pilot in a way.
Where did the funds come from, Sam, for the pilot?
So the funds would have come from the developer. Yeah, so the developer is the one that would have taken the chance with this system, invested in the future, really, because in 2008 to put down an advanced system like this, so I would say, yeah, that it's all kudos to the developer in that regard, and also to us that sold it to him, I suppose.
Yeah. Any other questions?
Terrific. I think it's terrific, Ignatius. I know you and I have been harping on about water reuse, wastewater reuse for so long as a way of meeting scarcity, or one of the ways of meeting scarcity, rather than keep building desalination plants. So I'm really happy to see this, Sam. It's a great project.
Yeah,
Thank you.
Kevin, go ahead, Kevin.
Yeah, I just want to echo what Valerie was saying. This is an exciting, successful project that I want to learn more from you about. AWWA, the American Water Works Association, sponsored a water reuse workshop at CWWA in the Bahamas 2 years ago, and we had some great interest from the crowd. And I'm really interested in your treatment levels and learning more what led to that selection. It seems like it gives you more flexibility on what the end user can do with the water when you treat it to that level, the high level of treatment. And instead of just focused on like irrigation or something like that, you're able to use ponds and irrigate, and just as an example. So hats off.
Thank you. Yeah, and I think the residents themselves, are getting a savings on their water bill, right? Because the use water that they use for flushing the toilets and watering their lawns and whatever, washing their cars, is actually at a discounted rate to the Barbados Water Authority drinking water. And you shouldn't be using drinking water if you can avoid it for those purposes, right?
Yeah.
So it's a very good it's a great case study, I think, for the water reuse. I mean, all of our other systems are reuse water, but a lot of them are hotels, and of course they see their value in a different way when they're doing irrigation for their lawns and, I don't know, beautifying their property, because it makes people want to stay there. Or for golf courses, that's a big one across our reuse profile, because that's a huge cost to keep water on a golf course and keep the fairways green and stuff. But yeah, this is a favorite one of mine as well. And I would like to see more of this type of thing. And so we've been pushing to help with the financing aspect as well, because not every developer is ready to jump forward into this and not risk, trying to go into a commercial venture that they don't particularly know about in terms of wastewater reuse. But we are, and that's one of the things we've been trying to push. Yeah.
Good. And great presentation too. Thank you.
Thanks, Kevin. Appreciate that.
Thank you, Kevin, for your intervention. Just to mention before I go to the other three questions we have, that if you go to the Barbados Water Authority's website and their LinkedIn pages, you will find on the Water Wednesdays this week they presented on what the work ongoing at the Bridgetown wastewater treatment plant, where the 3 hours the project is ongoing. So I will, if you have not seen, I will say to the group, I will send the links through the chat subsequently so you could check it out. But this is some of the work going on in the Caribbean right now. And so it's a good model that we all can learn from. The next question was from, I think, Siobhan Placid of St. Lucia was saying, well, it's a sensitive question, but you may not wish to answer if you don't care to. What is the operating cost of the plant? And he also said that you mentioned about the gallons treated and the number of households. And he asked how many or how much land space was used for that plant.
Well, the second question is easier first. The space, as I said, the plant itself is about 31 meters by 19 meters. So it's relatively small. And then we have the reuse area. I can't remember the full footprint with the reuse tanks. But I could probably look that up for you and maybe send it in a information chat later. The operation cost, I don't know the figure off the top of my head, but I could tell you the components that make it up. Obviously, we have our operating management cost, which we charge to the developer. The next kind of major cost would be power usage, electricity, because it is pretty intense in terms of power usage, and that is hopefully to be offset in the future with additional renewable energy. So ideally, I mean, if we could move towards something where it was fully renewable energy set up, then that would be a tremendous, tremendous move. Yeah, I mean, those are the major costs there, other than life cycle replacements for things. I would say that with the charges that we're at right now at around the 100,000 gallons per day, it is still only a sort of break even type of operation. But I think once we maximize that bus, as I was using the analogy, once we fill the bus, then it will be like a revenue earning facility. And this is not the only one I've been involved in. We did a massive one in Jamaica for the Rose Hall utilities, and they are on a much grander scale. They're treating wastewater for a number of hotels that they collect water from, and they sell reused water back to them, and that is a full, like, they're making money from that. It's definitely a huge revenue earner for them.
Owen Gill asked, have you considered using the sludge for agricultural purposes?
Yes, I mean, I think that is the next step, but the right as the sludge comes off the sludge press, it is not class A sludge, which I think you need if you want to directly apply it to agriculture. But if you then solar dry it or compost it, you can then make it into a fertilizer once it's had enough heat that it kills off pathogens and things like that could be present. So that is definitely the ultimate aim is for, and I mentioned in the presentation, is for that sludge to be used as fertilizer, right? And the other great thing that can be achieved is that using the sludge, and especially the primary sludge, putting that into an anaerobic system, digesting that, and taking the gas to actually create further energy. And that's something that we're also hopefully looking at in the future, because that would complete the full cycle. So you would be getting reusable water, fertilizer, and energy from wastewater.
Right, I don't see any further questions in the chat. But this is surely a very enlightening presentation. As usual, and on Wednesdays, we have always try to get some of the best speakers for our Wednesday webinars, and where we speak from A to Z on water and wastewater, and try to expose our water utility operators and other partners to new and emerging areas in the water sector and wastewater sector. And as we try to find solutions for our water utilities in the Caribbean region. So I'd like to thank you very much. And I should also tell our audience that Ecohesion and sustainability, integrated sustainability, is an associate member of CAWASA. And we thank you for continuing to support us. And we'd like to thank Valerie for making all the connections so we can have some good presenters. Thank you, Valerie. And thank you all for joining us this evening. And we'd like to wish you all a very happy Wednesday afternoon.
Yeah, thank you very much, Ignatius, and thank you, CAWASA. It's very important to have this group in the Caribbean, and I would love to see it grow and grow and grow. So yeah, thank you very much for having us, and thank you everyone for tuning in. And I look forward to the next week's speaker.
Okay, I'm Ignatius Jean, the Executive Director of CAWASA, signing off on our CAWASA Wednesday webinar. And this is number 8. I had an error last week to say I was ahead of myself. It was number 7 last week, and this one is number 8. Thank you very much, all of you.
Ignatius, can you stay online just for a second?
No, I'll call you. I'll call you because
Okay.
this is being recorded. Yeah.
Okay.
Okay. Cheers.